Okay, so let's talk about SR Latch, which are very basic units for memory. There are more, let's say, better components in circuit like D-latch and flip-flops, but the SR latch is a very basic thing which on it are built other things like, I don't know, D-latch, flip-flops. So it's important to understand this component. So SR latch are used with their upgrades for example, memory usage for building memory. So, for example, it can hold values. So this SR latch will have the values 1 and 0 in it, and when there is no change, 0 and 0 will get into the inputs. It will just stay in the same situation. To understand this, look at the truth table. When we have, for example, 1 and 0 and 1, like here, 1 and 0, 1 for R and 0 for S, those are the inputs, set and reset it called. So you can see that the outputs Q and Q tag are 0 and 1. When I change the inputs and change it to 0 and 0 for S and R, what I will get that Q stays as the latch and Q tag stays as the latch. No change for what happened. This is the idea. So if I just give 0 and 0, it just keep the same values for Q and Q tag. You can see, you can think about it as memory or something. Okay, so how it works. Let's put an input. I put it 1 and 0, so I did this once. So we expect Q to be 0 and Q tag to be 1, but how it is decided. If we put here 1 and put here 0, note that here we have a OR gate here as well, and then we have a NOT. Now, if you see the inputs for each gate, you can see that one input comes from this, and another input comes from the other side, and we need this result to understand what is the input right over here. The same goes here. We have one input right over here, and another one that comes from here. So this is very perplexing because how do we know what is the input here or here? The answer is because in the start we don't really know what is going here and here. The answer is that you need to look at the values here or here that tells you what must be the result without knowing the other input. What do I mean? When we are looking on OR gate, when we have one input, doesn't matter what is the other one. When we have one input that is 1 with OR gate, we are sure that the result will be 1 because 1 or 0 or 1 or 1 both give you the result of 1. So here we will have the result of 1. But remember that we have a NOT. So on the result we are putting a NOT on this. So we are getting 0. So here I'm sure that if R is 1, it doesn't matter what I will get here, I'm sure that the result will be 0. So this I can say is 0. So here I can use it without knowing this one. Now I can use this one right over here. Why? And here I cannot use the same idea that 0 is, I know what is the result, because with OR gate I don't know what is the result using 0. It can be 0 if it's 0 as well, like over here, and it can be 1 if this is 1. So this is why in the gate in which I get an input of 0, I need the other input. In a gate where I get an input of 1, I don't need the other input. So this is how I can work with this circuit. I can use the gate that I get 1 inside, and in every one has 1 except for 1, 0 and 0, which no change is done, so it doesn't matter. So we'll have 1 at least with 1. I will look at it, get the result, and use it for the other gate. Here, I got here 1, so I'm sure that this OR will give me 1, and this NOT will translate it to 0. So here, I'm sure I get 0, so I can use it here. This is 0, this is 0, OR with 0 and 0 and 0, and while I'm now not on this 0 result, will give you 1. So here, what I will get is for input of R equals 1 and S equals 0, I should get q equals 0, q tag equals 1. So here it is. Q equals 0, Q tag equals 1 for S equals 0 and R equals 1. Just to test if we understood it correctly, let's assume, and here if I change, okay, let's assume, let's take another one, okay? Okay, it's not really. Okay, let's assume that we have another idea. Let's assume that this is 1, and let's assume that the other one is 1 as well. So what I know that this one will be 1 and this not, so this is 0. And this is 1, so this must be also 1, so this is 0 again, so here is 0. So we have 0 and 0, so 1 and 1 is 0 and 0. You can see? And for this one, 1 and 0, 1 and here is 0, what I will get is that this is 1, so this OR is 1, not is 0, so here I get 0. This is 0, so I need the result from here to be sure what it gives me. So here is 0, so I either get 0, 0 and 0 and 0, 0 not on 0 is 1, so here I get 1. So for 1 and 0 I'll get q equals 1, q tag equals 0. So for 1 and 0, 1 and 0. And here again, if s is equal 0, r equals 0, it would just not change. You can understand that this cannot be the first input, because if no change and I still don't have values for q and q tag, it won't work. So 0 and 0 as inputs, I cannot use it as the first inputs for this launch. So this cannot be the first one. One of that, I have to have one at least of 1. Okay, so this is the truth table, this is the launch. I try to show you how it works, and that's it. This is mainly for memory. It's quite a basic one. You have built on it like Latch, flip-flops, and different things. Thank you very much. This was about lunch, and that's it.